All right, welcome to part B, second video, continuing with 5.4. Now you can have that unit circle picture out in front of you if you'd like. But again, the whole point is that you're able to generate any of those answers without the use of a calculator, just by drawing a diagram. And that's what these questions are now going to put all together. So I'm going to do some of them, not all of them probably with you. The ones that are most important. So when you're given a point on a terminal arm in standard position, obviously the same steps still apply. So here we have the point -3, +4. First thing you do is you draw and label it. Before we can write any ratios, we need to draw and label and figure out if anything's missing and then find it before we can write our fractions. And then that will help us determine our alpha and our theta. So diagram first. So -3, +4. That puts us in the second quadrant. So that's how far we've rotated. If we go to -3, +4. Then you drop the altitude, right? Always to the x-axis, label -3, +4. R is what we don't know in this case. So the first thing we find is R. Using our formula, 16 plus 9. This is 25, which then gives us a nice answer, 5. So this is our specific triangle right now. We are then supposed to write all 6 trig ratios. So sine theta is equal to y over r, which we know is 4/5. And again, it should be positive because we're in that location. Cos is x over r, which is -3/5. And tan of this angle is equal to y over x, or slope, -4/3. This now helps us find cosecant of theta, secant of theta, and cotangent of theta. So we have 5/4, -5/3, and -3/4. Again, if it's negative, it stays negative. If it's positive, it stays positive. Flip the fraction. Nobody owns the negative in the equation. Determine the related acute. So you see that there's a little alpha guy in there to get to the x-axis. Doesn't matter which one of these 3 that you pick. I'm going to show you, won't matter. I would suggest, though, that if any of them are negative, you just pretend the negative is not there. So if, for instance, you used cos, just to get your alpha, we're going to inverse the cos of +3/5. That way you always know you're getting your first quadrant answer. So 53 degrees. If you had done -3, you notice that it gives you the second quadrant answer right away. Now that's not always going to happen. So just to be on the safe side, we're going to use our 53 degrees, so 53.1 degrees. That's how much this is. That means theta in quadrant 2 is going to be 180, which is the horizontal line, minus 53.1, which is your 126.9. So you would have gotten the 53 if you had done sine. What would you have gotten if you had chosen cos? So -4 divided by 3, tan. -53.1. So again, the calculator would have thought you were down here in the 4th quadrant, but you would have just flipped that answer and reflected it to get that interior corner up here. So it's still 53.1. Now, you're being asked to repeat the question for a different location. So same question, just now we're going to be at -7 and -24. So you're going to draw again -7, -24 puts me down here in the 3rd quadrant. So there's my theta. I'm going to label everything. That's step 1. Draw a triangle. X is -7. Y is -24. This is R. We have to find R. R squared equals -7 squared plus -24 squared. And 576 plus 49, oh, look at that. Whatever the square root of 625 is, r is 25. So with an r value of 25, we don't again have to break that down. That's already a perfect whole number. We now are going to write our ratios. So again, you can write your sine, your cos, and your tan. Sine should be negative, negative 24 over 25. Cos would be negative 7 over 25, but tan would be positive. The slope of this line is positive. So opposite over adjacent, 24 over 7. Negative over negative makes positive. And again, you can flip these to get the, reciprocate them to get the cosecant, secant, and cotangent ratios. So again, cosecant is 25 over 24, still negative. Secant is 25 over 7, still negative. And cot is 7 over 24, positive. All right, then you pick one. Again, it won't matter which one you pick. Just drop the negative. So I'm going to start with the sine one. I'm going to drop the negative because I just want to get my alpha right away. And the calculator won't understand where I am anyway. So 24 divided by 25, 0.96, shift sign, and we get 73.7 degrees. So that means the interior corner here is 73.7 degrees. The calculator thinks the triangle is over here. It's giving us this amount. But all we're going to do is translate that amount into the corner that it's reflected in. And now add it to 180, right? Because now we're in the third quadrant. So theta in quadrant 3 is 180 plus whatever this alpha is. So 180 plus the 73.7 answer. And that should be obviously 253.7 degrees. All right, so that's a point on a terminal arm, which you have now seen multiple times. All right, let's continue on. How about if I give you an exact value and I ask you to give me back the ratio? So given the point 0, negative 1, what are the 6 ratios created? So let's think about the location here. On that unit circle, where would we see 0 and negative 1? So 0 on the x, negative 1 on the y. So if that was the point on the terminal arm, how far did we actually rotate? Well, that would be 270 degrees. So this is another way of asking you, what are the 6 trig ratios for 270 degrees? Really is what it's saying. So sine 270 is worth the y value, right? Cos 270, you're going to give me back the x value. Now this is where it gets interesting. Tan 270 is slope. Now the slope of a vertical line is undefined. So that's the way you would say it. It would be negative 1 over 0. And you know that you can't have 0 on the bottom of a fraction. So because it's undefined, that's the way we leave it. Now when you do the reciprocal to sine cosecant of 270, so negative 1 over 1 is still negative 1. That's not going to change. Secant 270, so 0 over 1 becomes 1 over 0. That becomes undefined. And tan matches up with cot. Negative 1 over 0 becomes 0 over negative 1, which is just 0. So wherever tan is undefined, cot is 0. Wherever cot is 0, tan is undefined, because they are reciprocals of each other. Okay, so this was a very interesting question because it utilized one of those endpoints, in this case 270, in order, and it had a lot of ones and zeros. So this wasn't a special triangle question. This was one of those 0, 90, 180, 270 kind of questions. So they get all mixed in together. So let's do question 2, which is the exact values. As you can see, I have 4 listed here before we finish off this lesson with the last couple of them in the next section. So what do we have here? Determine the exact value. That means don't touch a calculator. You're drawing a picture. And what we need to do is we need to figure out where 180 is. Okay, so 180 is over here. So that's it in standard position. We've gone 180 degrees. I'm asking you for tan. Tan is equal to y over x, rise over run. Now some people will automatically just think of slope. What's the slope of that line? 0. Now, if that doesn't come to you automatically, fill in what the x value is and what the y value is at that location. So we have 0 over -1. So you still end up with the answer 0, which is what you should get. Tan 180 is 0, but this is y. It's the slope of this horizontal line. All right, next one, 450. Again, you draw yourself a diagram. Now, 450 degrees, if you're not sure where that takes you, 450 minus out 360 is 90. So we've gone 1 full time around plus an extra 90. So that's 450 degrees. Again, you land on one of these axes, which means we need the coordinates. The coordinates when you're located up here is 0 on the x, 1 on the y. Now, this is a cos question. So because it's a cos question, we're interested in the x value. And the x value is 0. And again, if you were to cheat, cos of 450, 0. Now, cosecant 800. Let's get an idea of where 800 is going to land us. Is it 800 or 810? So 800 minus, let's change this to 810 because this won't make any sense to us. So change that cosecant 800 to 810 degrees, please. So 810 minus 360 minus another 360 leaves you with 90. So we've gone around once, around twice, and then we land at the 90-degree line. So we're coterminal with 90, which again has the coordinates 0 on the x, 1 on the y. Cosecant, if you remember, is the reciprocal of sine. So if I get my sine answer and I flip it, then I'll get the cosecant answer. Now the sine answer is the y value. And the reciprocal is just itself, 1. So that really didn't make any too big difference by reciprocating it. And the same thing over here. We have cot of -360. So -360. Well, if we go up, it's positive. So let's go down first for negative. So -360 lands me there. I should have been writing those down as well. So what we need is 1 over tan of -360, and then we'll just flip our answer. Well, to get tan, again, the coordinates here would be 1 on the x, 0 on the y. It's 0 over 1. So 0 over 1 is just 0. And this would be undefined. So those of you that like to think about it, tan of a horizontal line is 0. So the slope of that would be 0. The reciprocal of 0 is undefined, which is what cot is. So you could do it mathematically by flipping your answer, plugging in the values, y over x, 0 divided by 1, flip it, 1 over 0, undefined. Doesn't matter how you go about it, you're going to get to the same place in the end. So it's important that you try these, check them over, and then we'll move on into the next and hopefully final section of this lesson.